Hello, this is Ralph Alvarado, and welcome to Exploratory Text Analytics. Today we're going to talk about a data model for text. This data model is going to make explicit some of the assumptions that we've been using in importing text in our previous modules, and it's also going to integrate the two kinds of modules we've already looked at. So the two kinds of models that we've looked at in the previous modules are the following. We've looked at text models, which describe the structure and function of what we've called text as text, in other words, discourse. We've looked at specifically the ordered hierarchy of content objects model as a text model that we want to implement, and in fact have implemented in our importing of text. We've also looked at text as message, according to Shannon's model of communication, where a text is a sequence of symbols drawn from a symbol set. We've also looked at language models, which describe the latent generative grammar of an information source, and which can be modeled as an n-gram probability distribution using the Markovian assumption, and which can be inferred from available text. So we have two broad kinds of model that we've been looking at, text models and language models, and we want to integrate them. We're going to integrate these into a relational model, a simple relational model that you can implement using SQL. We're not going to actually use SQL at this point. We're going to simply understand the model abstractly and implement it in CSV and data frames. So we've already been developing this model implicitly in our notebooks with pandas. We've got documents that we've been importing and converting, say from Project Gutenberg, and we've created vocabulary data frames and token data frames. And these three things constitute a rudimentary data model. So let's look at this a little bit more formally. The more formal description is this, and here I'm using a simplified entity relationship diagram to show the four main tables, units of information, if you will, that we've been working with and that we want to build on going forward. The first table to look at is the library table, which is a table that simply you can think of it as a bibliography, organizes all the information about the sources of our data, so that if we're pulling in, for example, hundreds of texts from Gutenberg, we'd want each row to stand for one of those texts, one of those novels. One of the columns would be the ID, another might be the author, another might be the title, the date, and so forth. This information in a lot of text analytic work and pipelines is often omitted, but it's really important to keep track of what you're doing. And also there are important features to be acquired from these data, because they can be propagated downward into your token table and can be features there. We'll look at that in more detail later. The next table I want to look at is the doc table. This consists of all of the chunks of text that you've extracted from your sources. And these can be paragraphs, they can be chapters, they can be arbitrary segments of text. They're called a corpus of documents in the analytic literature, although the term corpus is one of those words that is used differently by different communities. You can think of these as messages in Shannon's model. Each one is a message of a particular length or range of size. Like paragraphs have a certain maximum and minimum that's going to be different than the maximum and minimum of a sentence, say, or of a chapter. And this model is something that we have already represented in our notebooks using the OCO index to the token data frame. So let's jump to the term table. The term table is the distinct set of terms that are used in a text. You can call this the token type. And it usually consists of the distinct set of terms that are used in all of the texts that come from a particular library that we're working with. Sometimes this is called a vocabulary or a dictionary, but in essence, it's the symbol set in Shannon's terms from which particular symbols are drawn and selected from to create a message. Finally, the token table consists of a juxtaposition or joint distribution, if you will, of a particular position in the ordered hierarchy of content objects and a particular term. It's the co-occurrence of those two things. that constitutes a symbol sequence. We'll look at the specific features of a token in a second, but this is really the meat of the data model. This is where all of our important data comes from. And in fact, as we saw, we use the token table actually to reverse engineer the term table. So it's super important. Oftentimes a token is called a word, but we're going to try to stick as much as possible to the term token. Excuse the pun. More specifically, drilling down into the fields of each of these tables, the library table will typically consist of an ID for each source, a title, a date, an author, a platform and or publisher, and any other data that applies at that level to the source itself. The document table is going to consist primarily of the levels in the ordered hierarchy of content objects, sometimes labels, and sometimes model attributes that we can apply after the fact to our data model. The token table, as we've just seen, is a juxtaposition of an ordered hierarchy of content objects ID and a term ID, what I have here. And in addition, it'll have a sequence number, where that juxtaposition occurs. Sometimes that sequence number is actually part of the ordered hierarchy of content objects. And it consists of a particular string, which is the raw string of the token. The term is going to be a normalized version of the string, and here oftentimes you want to preserve the string in its raw form, say if it's got capitalization or a hyphen in it or something like that. This table can also have NLP attributes. It can have model attributes that are added by particular analytic models that generate data that then can be put back into the data model. Then we have the term table, which consists of a unique ID for each term, a normalized string for that term, and also NLP attributes in addition to those of the token. And we'll get into the distinction between NLP attributes when they apply to the token versus when they apply to the term. More common in the term table are statistical attributes such as the frequency of a term, or its inverse document frequency, or its entropy, or things of that nature. And it also, just as in the token table and in the document table, there can be model attributes applied to terms. Just to pull an example, randomly in principal component analysis or in topic modeling, there are going to be attributes that apply to each term pulled from that model, just as there are attributes that apply to each document. Here I want to look at this model in a larger context, which is the relationship between text in all the particular forms that it can take when we're looking at it from an analytical perspective. I call these the forms of text data. And they go from form 0, which is actually not structured at all, except in the basic form that they are found in, all the way up to a highly structured set of textual data that could be used as the basis for a database-driven web application. So in F0, you simply have text in its source format, such as plain text, as we saw with the Project Gutenberg files, but it could also be XML stuff, like something from the Text Encoding Initiative. It could be in JSON, it could be in CSV. There could be text coming in a lot of formats depending on where it's coming from. Now there's another form that we actually haven't looked at, but which we'll have occasion to, that I call machine learning corpus format, which is a minimum structuring of F0. And this is where you take a text from a source and you simply convert it into a table of strings for each document and have an ID for each document listed. And sometimes that ID is not even listed, it's just the offset of the list of strings that becomes the ID. I'll show you an example of that in a second. But basically, this is a minimal kind of structuring that a lot of text analytic libraries expect. So scikit-learn, GenSim, TextBlob, and others expect data in this particular format. What we're looking at today, and what we just looked at, is what I call F2, form of text level 2, which I also call standard text analytic data model, or the standard text analytic data model. And this is a normalized set of tables, including the document, token, and term tables, as well as the library table that I showed you. And it's often produced by the tokenization of F1 data. F3 data is built on F2, where we add annotations, NLP annotations to the data. We're going to look at some of that this module. And the rest of the levels are further additions to the model using the results of various analytical processes. I'm distinguishing between deterministic and non-deterministic features that we can pull out from these models. We're going to look at those in more detail in the rest of this course. And then finally, the last level is where you've added data to the tables to support the development of database-driven web applications. So here's an example of the machine learning corpus format that I mentioned earlier in the previous slide. And you can see it's very simple. Typically, it consists of an ID for each blob of text, if you will. Each segment of text is often just a long string. Sometimes there's a document label or two added as well. What you've done here is simply chunked the texts into a corpus that then can be fed into any one of these text analytic libraries available in Python or any other language that you have available that you're interested in working with. Here's a way of looking at the data model as well when we start to add extended data, such as we did already with the n-gram modeling of our texts. You can think of basically text terms and tokens as special cases of n-grams. That's what they are. A token is a unigram token, and a term is a unigram type. And so that if we're going to be adding bigrams and trigrams, that's where that data would land in our data model as basically extensions to the token and term tables.